Thank you. Um, First of all, let me thank Dr. Waller for inviting me to be a part of the Master Your Future series. And thank you to all the students that are taking the initiative to be here and listen to different perspectives on what a career after graduate school can look like. So the title of the talk is Entrepreneurship is More Like Academia Than You Think. And it is, but here we'll touch on high level similarities and give you an overview of some of the characteristics that you should develop and a lot of the concepts that you should keep in mind that can help make you a successful either researcher or a successful entrepreneur, whether you decide to pursue a career in academia or in entrepreneurship. So there are some traits that are going to be described in this talk that would be beneficial to you. Even if you're planning to work in an established company, but the main focus of this talk is if you're going to start your own company or if you're going to go into academia. If you have any questions about what some of those traits are, if you want to work in an established company, you can always ask at the end of the talk, or you can reach out to me via email. And I'll be happy to share my thoughts with you. So the format of this talk will be, first I'll tell you a little bit about me, then I'll go into my technical and business backgrounds. I'll give you just a little bit of the fun but serious things that I've done in my life that has made a significant impact on how I view life in general and how I view working with others. And then we'll jump straight into a comparison between entrepreneurship and academia. And then I'll give you a few important tidbits that you should keep in mind when considering a career in academia or in the startup world. So about me, I'm originally from Jamaica, specifically Kingston and St. Andrew area. Kingston and St. Andrew are parishes, kind of like parishes in Louisiana, but they're really close together, and so they're always mentioned in the same sentence. Of course, some of you might know the two of the most famous Jamaicans, Bob Marley and Usain Bolt. I was born and raised there. I graduated elementary school and high school there, and then I came to the States for college. So I received a bachelor's in environmental engineering from the University of Central Florida. My main focus was in water treatment, and I worked briefly in environmental engineering consulting. I hated it and went back to school and got a master's in chemical engineering from the University of Florida. My focus there was in nanotechnology, particularly self-assembled nanoparticles for applications in sensing. Then my wife got a job in Houston at NASA, so I decided to move to Houston to finish up my PhD in chemie. So I went to the University of Houston. There I focused on developing point-of-care diagnostics, but we applied a knowledge of both chemical engineering fundamentals and ligand-based molecular interactions. So interactions between DNA, RNA, proteins, and surface chemistry for developing these diagnostics. Then eventually I went to the University of Houston, the Clear Lake campus, and got an MBA. The specialization was in management of technology, which is their entrepreneurship specialization program. So now I need to qualify a part of my talk. I've never been a professor, but I did receive a fairly significant amount of training in academia in preparation for becoming a professor. I was kind of being groomed for it. I just took a different direction. I did receive a National Science Foundation fellowship, which focused on science and engineering pedagogy. So in addition to my regular lab research, I also had to do research on comparing and contrasting teaching methods among various industrialized countries. I had to design lesson plans, and I had to teach classes all the way up from the science classes all the way up from middle school through high school to the university level. I also received a Future Faculty Fellowship, which, as the name suggests, it teaches you the ins and outs of not only landing a faculty position at a university, but also it went into details about, you know, how to start up and maintain a research lab and a funded research program. I was also a postdoctoral associate for a little while for two mentors, one of which was a member of the National Academy of Inventors, and the other was a member of the National Academy of Engineers. So there was some pedigree there. It was lost on me, but they're the ones that have the pedigree. So that's just my educational background. Let me go a little bit into my technical background. So the majority of the work I did focused on developing point of care diagnostics. One of the big things that affect the trustworthiness of diagnostics is how well that diagnostic device or that system can differentiate the signal that's meant to represent your target. For example, if you're detecting the coronavirus, you want to make sure that the signal that you're getting is actual signal from the coronavirus itself and not from any background noise or any other virus that you're not trying to detect. So one of the ways we accomplish this differentiation is by developing what are called reporter particles, which are just essentially something that tells you that the virus is there. And these reporter particles, we try to make them as easily distinguishable from the background noise as possible. So one of the first projects I worked on, we used what are called retroreflector particles to detect both bacteria and viruses. Retroreflectors we use are pretty much micron scale mirrors, and they reflect almost 100% of the light that's incident upon them. But because they're retroreflectors, this light is reflected directly back to the source, regardless of the angle at which you shine the light from. So if you look at a regular mirror, if you shine the light directly from 90 degrees in front of the mirror, the light will bounce directly back to you. But if you move to a 45-degree angle and you shine the light at the mirror, that light will bounce away from you at another 45 degrees. With a retroreflector, if you shine the light at 45 degrees to the mirror, that light will be directed right back at you regardless. So we use those particles and we engineer them in order to capture both bacteria and viruses. And these particles are very easily distinguishable from any kind of background signal, because the only time you're getting a signal is if you shine a light at these particles. And it's essentially like looking at a car at night with its headlights on. It's very, very, they're very, very bright, even though they're micron scale, and you can use a cell phone to detect them. Another technology that we worked on, phosphorescent particles. This technology actually turned into a startup that I'll mention a little bit later. These phosphorescent particles are essentially glow-in-the-dark particles. They're similar material to what are in glow-in-the-dark toys, or those little stickers that you see that you usually have in kids' rooms. There, you put the stickers on a ceiling, you shine a light on them, and then you turn off the light, and they're glowing, like glowing stars for minutes. These particles are distinguishable from fluorescent particles in that the emission lifetime of these particles are on the order of minutes rather than milliseconds. So you can use a cell phone, you can use very simple optics to detect these particles. Another one, we actually engineered viruses to detect other viruses. And I mean, in this context, in this project, there was a lot of not only genetic engineering involved, but also a lot of directed surface chemistry. And in all these systems, there was a very multidisciplinary approach to developing these projects. There's a lot of cross-cultural work, if you will. In our lab, we had a lot of chemical engineers, but we also had biochemists, biologists, biomedical engineers. So there was a lot of cross-fertilization with ideas, which is something I would advise a lot of you to do. Don't just stay in your own silo. If you're a mechanical engineer, speak to an aerospace engineer, speak to a chemical engineer, speak to an electrical engineer. About your project, about their projects. Try to learn a little bit more. You'll not only get a familiarization with your own technology in having to describe it to somebody else that's not in your field, but you'll also learn a little bit about the techniques that other fields use, and you'll also learn a little bit more about the technology, and it might spark some interest. Beyond those, that was specifically in grad school, I did do some work in industry developing wearable biosensors for the DoD. If you imagine something like an Apple Watch or a Samsung Galaxy Watch that could test your sweat and or blood. In this case, it was a device for detecting blood coagulation disorders. I also worked on some other biosensors for the military, wearable biosensors for the military, but I cannot mention the details of any of those because they're not only they're proprietary, but they're also, some of them are also actually classified. Now, during this phase of life, a lot of these projects were funded by grants that I either wrote or co-authored. So I was a principal investigator on quite a few of these. I was also a co-investigator on others. So that's my technical background. I'll give you a little bit about my business background. These are a list of the startups that I co-founded or was a very early employee in. I did do some work out in industry, which is indicated by the dates here that don't have any company names associated with them in 2007, 2016. But my first real company was Caribbean Computers. It was founded by myself and a friend of mine in undergrad. We did some work building computers and repairing computers. The Compaq and Hewlett Packard were the biggest companies of note back then, and they were charging upwards of $3,000 to $5,000 for a desktop computer. We could source parts from a local wholesaler and build a computer for less than $1,000. That was comparable, and we could sell it for $1,500. So we were doing that. We eventually branched out into setting up servers for local businesses and whatnot. Eventually, that company failed because the big players were reducing prices and basically offering much higher quality products for cheaper prices. So we couldn't compete. We had to sell the company. In 2014, during grad school, during my PhD, the phosphorescent particle project turned into luminostics. That company is still progressing. In 2015, I was recruited to be a very early employee slash advisor for Zenith. This is a software as a service company. It's a biometrics company. They do artificial intelligence and machine learning. Not in a technical, my role was not a technical role. It was mostly business development. And in 2017, I also co-founded a company called Disruptive. Its specific goal is to develop diagnostic devices for detecting antibiotic resistant or antimicrobial resistant organisms. So here are just a few of the valuations of the startups that I was involved in. These valuations are based on either the most recent price round, which is the money, which is how much investors paid for each stock multiplied by the total amount of stock on offer, or a sale price in the case of Caribbean Computers, or the total amount of assets and money invested in the case of Disruptive. As you can see, you know, these valuations, depending on the company stage and what you've done and what's already invested, it can vary wildly. I don't have any billion-dollar unicorns yet, but hopefully at some point we'll get one. So just one bit of fun stuff. For about 10 years, up until 2019, I was a firefighter, being promoted all the way up to lieutenant in the fire department. This was a very impactful period in my life because as a scientist, as an engineer, we tend to be very involved in our thought process. All right, we tend to think a lot, evaluate a lot, and sometimes that can lead to what's called analysis paralysis. Right, you analyze a situation for so long that you end up not taking action, and this is something that used to happen to me quite a bit. And my foray into fire and EMS kind of brought me outside of my comfort zone and put me in a position whereby I had to make decisions. And a lot of these decisions were made with very incomplete information. And this is something that actually helped me quite a bit in both entrepreneurship and both my research. Like sometimes you just cannot sit down and analyze the situation forever. You have to take action, you have to do something. And then once you've done something and you've seen the results, you can iterate from that moment and move on. This time in life also has taught me how to interact and work with people from many different backgrounds. There were other people here who were engineers and you know, some had PhDs, but many did not. Many did not have college educations beyond associate degrees in fire or in EMS. So, you know, it took some work to learn how to distill a very highly technical discussion or a very highly technical concept into something that's very simple for someone to understand. So that also helped in kind of grooming me to communicate my technical concepts directly to others. And it was fun. There were a lot of fires. It was fun and dangerous. There were a lot of fires, a lot of other stuff, but it was a great moment in time. So now that I've finished about me, let me go directly into, you know, what's it like? What are the similarities between starting up your own lab versus starting up your own company? First, let me go over a couple of definitions for you to keep in mind while I continue to talk. What's an entrepreneur? Entrepreneur is a person who organizes and operates a business or businesses, taking greater than normal financial risks in order to do so. So that's the direct definition from dictionary.com. I crossed out financial because the risks are more than just financial, right? There are many other risks there are risks to your mental health. There's a lot of stress involved. There's relationship risks. Um, so it's not just financial. It's a lot of hard work, and um, you know, it's just more than financial. A startup is defined as a young company founded by one or more entrepreneurs to develop a unique product or service and bring it to market. You could read the rest. I would, in my opinion, I would also strike out unique. Your startup doesn't necessarily have to have a unique product or service. That is not, it's exciting to have, but that's not absolutely necessary. You can have a startup with something that's already out there. You've just made a slight modification to it, and you can still be successful. It's how you approach bringing that product to market that is important. So I've taken this image from online, and it kind of represents the process for building a research program. There are some differences here or there depending on which institution you go to, but essentially you start out with a research area that you'd like to focus on. You plan and you strategize how to, how to start your research program, and you kind of have an idea of where and which direction you'd like to take this research program, depending on whether or not you can get funding. In some cases, you do some preliminary work. If you've received a faculty position, you will have some startup funds that you could do some preliminary research. You could do some publications. You might have publications from a postdoctoral position. Kudos to you if you can use that. And then you could leverage that work, that preliminary work, that proof of concept work, in order to get grant funding. In some cases, publication and grant funding can be reversed. So you can, apply for grant funding, and then once you've done the work, you publish, and then that results in realization of your research plan, right? You've actually done some work. You've proven that this is a valid research area, and you repeat the process. You end up with some success. Now, here's the difference between building a research program and starting a company. Not much, right? With a company, instead of a research area, you start with your idea. You plan, you strategize, and then you go out, talk to people, market your idea. This is similar to publishing, right? You go out, you present your idea in front of people, reaction. You can take that reaction to someone who will give you either investment dollars, or you can parlay that market reaction into funds. If you already have a product, you give them, you get that early market response where people are buying your product, giving you money. You can parlay that money into financing, and then once that cycle continues, you've actually actualized a business, and that can lead to success. Of course, no company is ever successful on just one product. So just like in building your research plan, you'll have to, the cycle has to repeat. So either you're improving on this product, or you're broadening your product line, you're developing more products. But this is the essential process, and they're very, very similar. So what are some of the traits that a researcher needs to have, right? In order to both land your professor spot and also build your research plan, build your research program, right? You have to be someone who can sustain a research program, right? Is what you're working on a topic of contemporary interest, and is it fundable, right? If no one thinks your research area is significant or is of significant impact or interesting, the unfortunate reality is that no funding agency will really give you any money. The problem with that is also that whatever is interesting and contemporary will always change with time. So for example, over the past 2 years, coronavirus, COVID-19, SARS-CoV-2 has been the most contemporary, the most interesting contemporary thing, right? And it's the most funded. I can tell you that one of the companies that I co-founded received a very large grant from the government just for producing diagnostics for SARS-CoV, right? That would, I can honestly say that would never have happened. They received upwards of $25 million in grants for that product. That would never have happened without something like COVID, right? But with the advent of all these vaccinations and whatnot, we can almost guarantee that in a couple of years, funding for SARS-CoV research will probably dry up, or at least decrease heavily. So you need to be flexible in terms of what you're thinking about. Universities always want their professors to hit the ground running. I mean, they'll facilitate some training programs. Your colleagues will help you get on your feet, but kind of one of the reasons many universities, many programs require their brand new professors to go through postdoctoral programs. It kind of trains you to look at your work more professionally. They give you a lot of training in terms of writing proposals and a lot of these things that are needed to kind of hit the ground running. So, do you know how academia works? Do you know which funding agencies would likely fund your research? Have you ever written proposals before? Have you mentored any students? Can you network? I want you to know that, can you network? Networking is one of the biggest things that you should try to do. You should practice. And networking is pretty much just going out and talking to people. That's all. Just talk to people. It can be random conversations. It can be directed conversations with specific topics. But just go out and talk to people. People know you. It's the main thing that you can do to not only, just know people, but also to build your brand so that you can become recognized as somebody who's knowledgeable in your field and respected in your field. But taking a look at these characteristics, take a look at what an entrepreneur needs to be. Similarly, an entrepreneur needs to be somebody who can sustain a company. Your product needs to be of contemporary interest and is fundable. What fundable is can be whether or not the market wants to buy it, or if an investor thinks it is interesting enough and that there is a market there for your product, for your idea, that they can put money into your company. Just like research areas, what is fundable and contemporary can change with time. There's some technologies out there that were great 5 years ago and everyone was buying it, but now no one will ever buy that, right? Like, who buys MP3 players anymore? No one. Just like a university, investors also want their entrepreneurs to be, running They want to be running already, right? Do you know how business works? Have you identified your addressable market? What an addressable market is basically who out there will actually be willing to buy your product? Who out there has a need for or your product? Who out there has a problem that your product solves that problem? And not only that, but you have the means to get your product into these people's hands. That's what an addressable market is, right? The people out there have the money and they're willing to buy your product, but you must also have the capability of getting your product into these people's hands. That's how it's addressable. Have you written proposals before, especially if you're developing a technology startup? Grant funding in the form of small business innovation research grants, or small business technology transfer and research grants. These are very important, and these can actually provide quite a bit of funding for product development, which would free up investor capital to allow you to actually, expand your business. Have you obtained any prior funding? Right? Do you know what it takes to go out there and essentially beg people for money? Can you network? Networking in business is huge. Not only for collaboration, but also, again, to build your brand, to get out there, to let people know that you are operating in this field. So similarities in terms of entrepreneurship and academic employment. There are quite a few studies out there which bear out the facts about the similarities. But in the three kind of different areas, the person job role, you as the academic or the entrepreneur in your role, what are the similarities that both job types provide? There's a certain personal autonomy, right? You can kind of direct which area you want to go into, right? Which research area, or what is your product? What is your product idea that you want to investigate? You could develop big ideas. You could your idea. The size of your ideas is, you're the only limitation to the size of your ideas. Implementation is different, but just generating the ideas, you're the only limitation in both respects. You need to have some project management skills, project management, time management, a keen eye for staying within budget. You need to have fundraising skills. It's not just writing grants, talking to people. You might, in your role as a professor, you might have to talk to people from industry to get sponsored research programs, all right, to get some sponsored research. Or you might have to collaborate with somebody from industry to get a piece of equipment, or work on a specific project. We have one professor that's trying to get a drug from industry in order to investigate some other potential effects that drug might have. So you might have to go out there and talk to people and to get either funds or that collaborative work done. Within the structure of both environments, there's a lot of uncertainty, right? In a research program, you don't know where it's going to end up, right? You have an idea, but you might start doing some research and then it takes you in a completely different direction. You might hit roadblocks, it takes you in a completely different direction, or you might have some really, really enterprising students that realize that, there's something more interesting in this direction, and you have to take that. Similarly, in business, you might have an idea, you don't know everything. So once you've developed your product, you might put it out in the hands of the market, and then people end up finding a completely different use for it, or they might find that a lot of the features that you have don't make sense they might have to go in a completely different direction. There's limited long-term career development, right? You know that as a professor, you're going to be assistant professor, associate professor, and then a full professor. Beyond that, there's not much set, there's not much structure in terms of professional development. If you've started a company, you are essentially an executive. You might be the CEO. You might eventually have to leave as the CEO, but what's there above that in terms of career development? You have to guide yourself. You have to have something. You have to be willing to learn, be open to learning in order to develop yourself. There's freedom and flexibility in both environments. Again, you can determine what you want to do, where you want to go. There's autonomy in terms of determining when, where, and how to work. This mostly covers the culture of your organization, whether it's your lab or your company. You can determine, how your team views the company on a whole and the work that they're doing. Within a group setting, your motivations are normally intrinsic. You determine, how excited you are about the work you're doing. There's an encouraging work atmosphere. Usually, it's very exciting if you're in a startup. Very stressful, very exciting. It's also very exciting if you're, building your research lab, because you're starting a new program in a new direction. And there's a lot of collaboration opportunities in both environments, and you can build very, very strong relationships with other founders, people within your company, or other collaborators in the university. With that said, let me kind of wrap up. I think we're at 12:40, sorry. Let me move through the rest of the slides real quick. There are 4 basic characteristics for success in both entrepreneurship and academia. You as a person, you have to have the vision, right? You have to know, you have to have your idea, have your plan, and keep in mind where you want to go, right? That's essentially your vision. But you also have to have a tolerance for ambiguity and a tolerance for failure. What tolerance for ambiguity is, you don't have complete information. You don't know everything. So with that incomplete information, you have to realize that there's some ambiguity there. And you may fail. Your vision might not be correct. You may fail. So you have to maintain some level of flexibility and be creative. In your creativity, you can find different avenues to either pursue or different ways to overcome that ambiguity or that failure that's inherent in either entrepreneurship or research. So the process to start a company, I won't go into the details, because the details, how much you pay, to which forms you need, that's all stuff that you can find online. But it's an iterative process, right? First, you need to know what the problems are in the area, which is similar to what's in academia. Then you need to screen those needs, right? Which are important enough to pursue. Which have the biggest markets, which have the most addressable markets, which areas will probably be funded the most. You screen those, you generate concepts, you see if those concepts can work by screening them, and then you implement you develop a strategy, and then you implement. Always keep this process in mind for whether or not you're either starting a company or developing or planning to pursue some research area. In doing the first 2, the identify and the invent phases, talking to people, networking is essential in these 2 areas. Again, you don't know everything, so reaching out to people, talking to them, finding out what, getting other perspectives, very, very important. Important information, I guess I can provide this to many of you in a PDF format after the presentation, but you need to know as an entrepreneur or even as a researcher that not all technology will spawn viable businesses. Not all ideas will result in successful research programs. Communication skills are essential. Legal responsibilities can be daunting. None of you are, I'm going to assume that none of you are lawyers, and none of you want to pursue law after this. If that's the case, just get professional help. Very important. It's not necessary to have a business plan, but it is essential to plan, which is different. Most people don't care if you have a business plan, but they need to know that you have a plan and a strategy for how you're going to accomplish running your business. In both cases, you need lots of money. In both cases, you have to work long, hard hours. In both cases, you have to be focused, but you have to be flexible, as I mentioned before, right? You have to be very nimble. You have to learn how to change directions without being too attached to all the work that you've already done. Learn the language of business, the terminology, and the concepts. This is important to at least sounding like you know what you're talking about when you're out there begging for money. Find your own path. No two companies are alike. Products might be similar, but the way your company culture is, the way your company functions will be very different from the other companies. Don't worry about how different that is. Just find your own path. Learn to negotiate. This is very important. If you're afraid of presenting or talking to people, originally I had partnered with someone who isn't, but I crossed that out. If you're afraid of presenting or talking to people, get over it. Practice, go talk to people. Very important. You cannot get away from it. If you're a professor, you'll definitely have to present. You definitely have to talk to people. If you are an entrepreneur, it's absolutely essential. If you're an entrepreneur or a researcher, be prepared to give up some ownership. You might come up with the idea, but if you have to collaborate with someone because you don't have all the requisite knowledge, you'll have to give up some ownership in terms of, for example, who gets written on the paper. If you're a startup entrepreneur, you might not be the CEO in 4 or 5 years. Like, for example, in my case, I know that my niche is in starting up a company and getting it to a sustainable place from the idea phase to that first set of investment money. I am not necessarily the person to run a company during the growth phase. You might not be that person as well, right? In some cases, investors, when they put money in, they might assess you as a founder and say, maybe the chief technical officer or the chief science officer is a role that's better suited for you. We need an experienced CEO who can take this company from this stage to this next stage. And you should be okay with that, because, I mean, an executive of a very widely successful company is always better than being the CEO of a failed company. So keep that in mind. And there's about 100 or so companies were surveyed, and they were asked 100 or so companies that failed, that closed up shop, and they were surveyed and they were asked, why do you think you failed? And the most common one, you could look at all the rest, but the most common one is, there was a product or service that the market doesn't need. This is something that engineers and scientists have a problem with a lot. You've come up with an idea, it's brilliant. In and of itself, it's great. You might think all you have to do is build it and people will buy it. That's not the case in business. You might think you can do the research and people will fund it. That's not necessarily the case in research, right? The market has to have a problem that your product solves. Your research idea has to have some kind of significant impact that solves either a gap in science, in knowledge, that fills a gap in knowledge, or solves a problem that's of concern, contemporary concern. How do you find this out? By talking to people, putting your product out there, talking to people. Does this make sense? Talking with colleagues about your research area. Does this make sense? Again, all of this boils down to networking. Now, the focus of my talk was, on the differences or the similarities between being a researcher or a professor and being an entrepreneur, but you can do both. There are some professors that have been successful entrepreneurs by co-founding companies and then maintaining some role within those companies, either as on the advisory board with some stock or active roles in governing the company. You can do both. Different universities assess those kinds of conflicts of interest in different ways, but it is possible. So here are just three of the ones that I picked off the top of my head because I know about them or have met them before. Chad Merkin from Northwestern University, his net worth is about $30 million based on his stakes in multiple startups with technologies that have launched from his lab. Bob Langer from MIT, his net worth is now $1.7 billion. He made his net worth increased from a few million to 1.7 billion over the last year and a half, just from Moderna, because the vaccine technology, the mRNA vaccine technology came from his lab. He only owns 3% of that company, and that 3% is worth $1.7 billion. Joseph DeSimone, he was originally at UNC. He went to Stanford. He's worth about $10 million, but this does not include his stake in Carbon, which is a company he launched about, 5-6 years ago, maybe. That company is now valued at $2.5 billion. That company does 3D printing. So with all that said, just two last tidbits. Talk to people, very important. Go out of your comfort zone, talk to people, talk to many different people. Describe your projects, talk to people about their projects, learn about other areas of research, learn about business, talk to business people, find some friends in the business school, talk to them about, whatever they need. And lastly, the choice is yours. There'll be a lot of no's. If you're begging money, from investors, you'll hear no a lot. If you're writing research proposals, you'll get rejected a lot. That doesn't matter. It happens to everyone. It's all up to you whether or not you want to build a wall that blocks you in, or you want to build stairs to achieve success. With that said, I'm finished. Thank you very much for your time. Thank you for listening in. And if you have any questions, I can quickly get to them.
So if you would like to, a small group, open your, turn on your mic and ask your question, you can do that as well. Any questions?
See, Jacob has his hand up.
Okay, Jacob.
Sorry, that was one of the applause reactions on Zoom. Um,
Okay, so you didn't have a question?
no, but I might be able to have one in a couple of seconds. Second.
Okay.
Can I ask my question?
Yes,
Yes.
sure.
Hi, and thank you for this great presentation. I loved it, and I think it was what I needed. You know, it was concisely prepared and very informative. First of all, I just want to say thank you for this. And secondly, yeah, I just want to have like a question that, you know, like I'm Rohaya and I'm a PhD student. And I always had this like opinion, you know, should I go to academia? But I see myself like more characteristic and more like desire going toward the entrepreneurship and, you know, having my own plans. And I think, you know, you perfectly, beautifully answered all of those things that I had like as a like challenged myself. Now that I'm like reaching to the end of this like journey of the PhD, and I'm clearing out my thoughts. There's a project that, you know, kept my mind busy, and instead of, you know, just ignoring it, and I started as a fun, I started working on it. I said, okay, anybody can have like any like hobby, and I just want to look at as a hobby because right now I have something that I need to like work on it. But like I started working on that as a project, and then after like more than a year, it's turned out, you know, like beautifully as I like answer some of the questions like what is the purpose of this project and what's like it's going to provide to society, what is the size of the market and how it's doable, and is it like new technology and it's not available like in the society. But I've reached a point that, you know, I think because I'm not familiar and I just started as a fun, but I'm reached a point that, you know, I see that I can't do all of it by myself because time matters. Like I know some technical part of it, but I'm not familiar, like for example, with very advanced coding and stuff like that. And it's better to hire someone to do that. And I was wondering that, you know, my question is for you is how we can start with the funding. You know, I have like this, I need to just write this proposal that what is this project and, you know, answer all the things that you covered in your presentation. But what is the first step and where is good to, you know, start for this? And I'm happy to hear your experience and advices for this.
Okay, great. Great question. So in entrepreneurship, there's no set way, there's no structured way for starting anything, right? So there are many different ways that you can achieve your goals. If you need someone who's a coder, hiring that person is one way. Another way would be recruiting somebody to become you know, a collaborator or a partner in this project. If your intention is to move to is to develop a startup, you might just have to recruit a co-founder, which kind of ties into one of the points I made. Be prepared to give up at least some parts of ownership, right? You might just be at a stage where you're the CEO level person, but you might need a chief technical officer, which would be whomever has those coding skills that you can recruit. At that point, you might not need that much money to compensate that person. You might just have to compensate that person with a share of the company. If your intention is to not do that and to seek funding, then there's the triple F, FFF, which is a term in the startup world that refers to money from either your friends, your family, or fools. It's not the fools part is not necessarily meant to describe the intelligence level of the people who are giving the money. It's just meant to describe people who are giving you money without really and truly knowing all the risks that are involved. And in some cases, you know, those people do provide essential funding for startups to get off the ground. So that's why it's still a part of it. But I mean, you can also apply to SBIR, STTR grants. This requires the company to be established at the time of award. So there are many different ways. There are many different ways that you can achieve your goal. It just depends on what you're willing to do. Do you want to give up some ownership? Then go out, talk to people, try to recruit somebody.
Yeah, sorry. Like, I'm just interrupting you because I've reached this point that, you know, I'm very open to share my idea, and I'm happy to just, you know, involve some more people with like more like skills. It's going to help, and it's okay to just, you know, like lose the ownership. But does this mean that, you know, you mentioned that for having a funding like from FBIR, you mentioned a couple of names. Does this mean like getting funding from government? Does it is it necessary to establish your company first? You fund your company, and then you can get some extra funding like from the government? Or is it possible to just you write a proposal and you know that, you know, this is a great idea and this is going to benefit the society, and you can start from there?
Well, S as in Sam, BIR, or STTR. These are specific. These are grants from the U.S. government that are specifically meant to assist or fund small businesses in developing technical products. In some cases, there can be collaborations with universities. In some cases, it doesn't have to be. Usually, there's some other requirements. Like, for example, it has to be a U.S. company and these kinds of things. But those grants, they can cover a wide area of topics. It doesn't have to, your company doesn't have to already have funding to be eligible for these grants. Your company doesn't even have to exist yet to write a proposal for these grants. Your company just needs to, if it is selected for award, it needs to exist in order to receive the money. You understand? So for example, your company can be entirely theoretical and you apply for the proposal. If it is selected for award, then you must go through all the process of filing the paperwork to establish your company with all the mentioned people who are in the proposal, being a part of the company, and establish bank accounts and all these things in order to receive the funding. Okay. There are some details involved there, but in many cases, technical founders, they get some money from either themselves or family, friends, and the other group of people. And that kind of funds initial proof of concept work. And then you can parlay that proof of concept work into a strong proposal that you could send to the government. Okay. To get funded.
Thank you.
Mm-hmm.
Jacob put in the chat a question, and we'll close out the session on this question here. It seems like many of your later startup stemmed from funded research. Do Do you have any tips or tricks for your experience with projects that are not strictly related to your academic field of study?
So in terms of ideas that you have no expertise in, or ideas that are outside of your research program?
It's kind of more like the latter. So like I work in a lab that's kind of more robotic focused, and
Mhm.
then so like there's some aspects of that that kind of transfer, but it's not like the focus of our lab. Whereas a friend and I are looking at more of a concept that kind of fits within a different industry as to what our research lab is looking at. So I guess kind of I was looking at more of like a time management aspect because they are semi-different and we're kind of keeping them separate. Did you have any like tricks that you found of like managing that?
No, there are no tricks. Time management, regardless of whether or not your entrepreneurial project is related to your current research project or not, time management will be a huge issue. There are no real tricks. You just have to realize that you have to put in the extra hours. The extra hours, in this case, your extra hours will be, whatever other work you need to do to develop that technology to the proof of concept stage, if that's what you're trying to do, or the business work, the business background research, the investigating whether or not there's a market. If your entrepreneurial project is related to what you're doing in the lab, you'll still have to do the extra work to do the business research, or your research trajectory within your lab, your funded work, your government funded research project might give you proof of concept for the idea, but it might be going in a different direction from where you need to go to develop a product for a market. So any other work that you might need to do to develop a proof of concept product might have to be done outside of your lab work, if you understand what I'm saying.
Yeah.
So for us, our research project, the one that turned into Luminostics, we were developing that, we were working on that research for testing herpes and other things. But to get funding for the company, we had to get our own money and fund our own research to develop that technology for testing of other STIs, like chlamydia and other things, because no one was funding, no one was giving investment capital or even grant funding for the other or SBIR grant funding for the other things that we were trying to do with it in the lab. So we had to pool together our own money and get money from friends, family, and others to do the other work, right?
Gotcha.
So
Understood.
it's just, yeah, time management is important.
Exactly.
Yeah.
Absolutely. Thank you.
So Gavin, I would like to say thank you so much for your presentation and for the students coming today. We appreciate you coming and participating. We look forward to having Gavin back in the future to do more workshops around this. If you have suggestions or ideas, please do not hesitate to reach out to me. Again, thank you, Gavin, and you all stay safe and healthy.
Thank you very much, Dr. Waller. You're very welcome. And if you all have any additional questions, feel free to shoot them to my email. I'll be happy to respond.
Thank you.
Thank you much.
All right.
All right.
Bye.
Take
All be
care.
safe.
Bye-bye.
You too.